Hey everybody, just want to say hello and ask you to, or just say thank you as well for being patient with being gone. I know we had our test, actually would have been today. Today's Tuesday. I will get it graded. I got your quizzes from last week. Sorry I'm not there to get some questions answered if they were. Just be patient. Trust me in terms of your grades, like we'll be fair. I'll kind of have an idea of how things are going. Once I grade them, see how it all goes, we'll kind of revisit if there's any questions, make sure we're all squared away before we go on. Anyway, moving on here, this section we're going to do today, rules of differentiation, I think you did last year. So most of this is going to be a review. So I'll hit on some of them. I'm going to gather that for the most part, a lot of this you've seen. So we'll kind of go through it again. The sub should have the notes with the key there. So if we don't do any, you should be able to look at them on that key, make sure that you're doing them right. All right, that said, we'll go ahead and get started, and I'll try to get through this fairly quickly so that you can kind of try the rest on your own. And again, I think you've seen most of these anyway. All right, here we go. Okay. What you just tested on was kind of the long derivative formula, like how we find the derivative of the formal definition. The limit as h goes to 0, so on and so forth. Most of you at some point hinted that you already knew all this or said that you knew all this. I made you do it the long way. Now we could do our shortcuts. So the table is just kind of giving you the way different functions can be named: f of x, g of x, y. The number of tick marks will correspond to how many derivatives we've taken. So since this is one tick mark, it's your first derivative. These over here would have 2 tick marks, it's going to be your second derivative. Just indicating how many derivatives we take. Obviously, if we were to take a third derivative, another column, you'd have 3 tick marks, so on and so forth. When we're given y prime, a lot of times we could also like do dy dx. If you remember, dy dx, we said is also kind of the change in y over change in x. It's just saying how much does y change as x is changing. And the whole idea of delta y over delta x is implying an interval of time, which when we're dealing with a derivative, we're not dealing with an interval of time. We're trying to deal with the idea of a tangent line to a curve at a specific time, like how quickly are we moving. So we change that delta notation, change in y over change in x. Ooh, my fingernails are kind of long, and they're dirty. Yikes. Okay, I'll get that afterwards. And then the dy dx is sort of the same thing, change in y compared to your change in x. We're just using the derivative notation dy dx to indicate that we're doing it as a tangent line, as an instantaneous rate of change. Okay. When we're using this notation, the number of exponents is kind of what's going to give us our number of derivatives. So if this is squared, it's a second derivative. If it was cubed, it'd be your third derivative, so on and so forth. Okay. All right. The rule that I think most of you know is the product rule. Not the product rule, the power rule. We'll start with that one, and what this is just saying is whatever your exponent is when we take our derivative, so this is y. For us to take the derivative, which is y prime, we're just going to take in, multiply it by the coefficient in front, and then whatever that was originally, we subtract 1 from it. Now, before we do this first problem, I do notation-wise want you to do something for me in number 1. What you're going to do is put parentheses around that. And then one of the notations from 2.4 that we quizzed on and tested on was this little d over dx here. The way that is used is kind of like in this situation here. It's kind of just saying if I have a d over dx, it's saying take the derivative or find the change in any of these variables as compared to x, or like since this is y written in terms of x, we want to take the derivative of y in terms of x, so that we could do one of two things here when we take our derivative. We could use the y prime notation, which is probably the easiest one that we would ultimately do the most. And then you're going to do your power rule. So you're going to multiply 7 times 11, 77 subtract 1 is 6. Or we could do, notice how this is y in terms of x. We could write this as dy over dx. The change in y over our change in x is equal to 77x to the 6th. So that's just saying, like on an xy plane, instead of like change in y over change in x, it's basically at that point our instantaneous slope of the tangent line would always be 77 times the x coordinate to the 6th power. Alright, it's sort of up to you what notation you're going to use. We're going to use that fraction notation, the ratio, today just so we can kind of get used to using it, but the tick mark is fine too. So with that said, number 2, you would say just dy dx, because we're finding the change in y compared to our change in x, and then it's just our power rule, 12x squared plus 2. Okay. These generally aren't too hard. The one thing to just be careful of are ones like number 3, where you're going to be dealing with a negative exponent. I would always take that extra step. Okay, I know you're all pretty bright kids and generally can kind of skip some steps without huge issues, but I would recommend in this case not skipping too many steps when it comes to this, because I just see a lot of people make mistakes with negative exponents. So I would first take this guy, bump him up. So we'll rewrite this. Don't put that yet. So y just equals x cubed. When we bump that up, it's now minus x to a negative 2. It's just easier to now see you have a negative power. So when we go to take our derivative, dy dx, it's just 3x squared. Now when we multiply, it should end up being a positive 2. X, subtract 1 from this to a negative 3. Okay, and that's pretty much our answer. Final answers, I will want positive exponents, so we would want to take this, drop it into your denominator. Okay. All right, 4, no tricks there. Again, just the power rule, multiply by 9, subtract 1 from your power. Same here, multiply by 3, subtract 1 from your power. 5, pretty easy in terms of the problem, but I just use some different variables just so we, again, understand how that would change if we're going to use that ratio of the dy dx. Since this is now an equation for y, and y is always equal to these values in terms of u, when we now do our ratio, if we're going to choose that option, and again, you could just do y primed, which probably long term is what most of us are going to do, but for this case you would do this as the change in y compared to your change in u. It'd be dy du, and then from there you just go through with your power rule, which is again easy. Multiply by 6, subtract 1 from that power. Here multiply by your 5, subtract 1 from that power. Multiply by 2, 8u, and then 5u, you do 5u to the first, I'm sorry, u to the 0, which is a 1, so that's why you're just going to get a 5. All right, that's pretty much the power rule. 6, again, is the power rule with a negative exponent, so just again be careful. Won't go all the way through it, but I would recommend rewriting that first as 3 times x to a negative 2. Plus 4 times x to a negative 1. So notice there's no tick mark here. All I did is some algebra bumping this up, rewriting with a negative power, so that now when we go through take our derivative, just kind of easier to see what powers you are working with. Okay, so that's our power rule. Pretty easy. I think most of you knew that already, and it's the one that we'll use the most. All right, the next, even easier, the constant rule is just saying if I give you a function y equals k, some constant, the derivative of that dy dx is going to equal 0. All right, that should make sense if you think about if I gave you this equation here. Let's do 7. By rule, what we just read here is the derivative of this should just be 0. Quick, simple, the derivative is 0. The reason for that is if you think about what y equals 10 is, do that over here. It's a horizontal line through 10, and you've known this for some time now. We've talked about how the derivative is sort of the calculus way of saying slope. So when it says find the derivative of y equals 10, it's basically saying find the slope of that horizontal line, and we've known for some time now that the slope is 0 for a horizontal line, and that's really all that is saying. So number 8, I kind of get tricky, or at least try to be tricky. Pi squared sort of looks like you would do the power rule, but in reality pi squared is a constant. Okay, it's like 9 something if you squared the pi. So that's just a constant, meaning your derivative still is going to be 0. Okay. 9 is just kind of a combo of them. Now that we have power rules here and a constant there, again, rewrite this as x to a negative 8 real quick. Okay, we'll do that one. So then we're done with that. Bump it up, and then we do our rules here. So the first two are going to require the power rule. So you're going to get negative 3 x to a negative 4 minus 8 x to a negative 9, and then since that 4 is just hanging out at the end, he would drop out. The derivative of 4 would just be 0, so it would be gone. All right, and then 10, pretty simple. Dy dx would just equal 12x to the 11th, and then the 7 is going to drop out. Okay. All right. Next one, product rule. Heard some of you talking about the product rule the other day. Product rule is used when we have two different functions being multiplied by each other. So if you look at number 11, we have two binomials being multiplied. We could, if we wanted to, in number 11, FOIL that out. So if you wanted to, you could FOIL that, end up with a polynomial, and then go term by term by term like we did above. But that isn't necessarily always going to work. You want to kind of know the power rule. Eventually, when we start dealing with sines and cosines and tangents and different types of functions is when the power rule is really needed. Sorry, that little loop is getting in the way there. Give me a minute. Okay, let's try that. All right, so here's the product rule. Basically, if you kind of look at what I have written here, you have u being multiplied by v. So our first term and our second term is being multiplied together. What the product rule is just saying we're going to do is take whatever our first term is. Notice how this is u primed. So if this was u, we're going to do the derivative of u multiplied by v plus u multiplied by v primed. V primed would be the derivative of the second term. All right, so what it really just means is you're going to take the derivative of the first and leave the second one alone. That's what this is saying. And then you're always going to add. Then you just do the opposite. You're going to leave the first one alone, multiply by the derivative of the second. All right. So for 11, first term, second term, and it's just that combination. You're going to take the derivative of the first. Let me see if I can do this and not get in the way here, so bear with me. Okie dokie. So here's our first term. It's going to be the derivative of the first. So this is our power rule from above. So the derivative of 9x squared, 18x plus 4. You just leave the second term alone. We basically just rewrite it. Okay, so that's our first part. From there, you're going to add the product rule, and you do the opposite. You do the opposite combination. You're going to leave the first term alone and multiply by the second one. All right, that's pretty much it. Long term, when we start dealing with some, we'll probably be simplifying these. I don't really care too much about you simplifying these right now. That would keep you busy for a while anyway. So it's just more right now I want to make sure that you know the rules, how they kind of work together and play out. So you can just leave that, okay? And then you can see my beautiful handwriting there, I'm sure. Well, it's a little embarrassing, but you get the point. All right, 12, kind of the same thing. You leave the first term alone, or I'm sorry, you take the derivative of the first, leave the second one alone, and then you're just going to add, leave the first one alone, take the derivative of the second. That combines your couple previous rules where you're just going to be doing the power rule, but we do have the negative exponents here. Okay, so you're going to want to bump this up, bump that up, probably before you go through all the work so that we keep everything straight in the sense of our powers and our signs. Okay, so that's the product rule. Flip that. Okay, let's see here. Next one, quotient rule. Quotient rule, if you kind of look here, I give you u over v. It doesn't necessarily have to be the u on top, the v on the bottom, so don't get hung up in always u over v when it's the quotient rule. There's nothing preventing me from putting like v over u. But basically u over v, just the same, we have a function that's a quotient. So if you kind of look, it would be something like this. We have two binomials being divided by each other, same here, binomial, binomial. Here's our quotient rule. If you kind of notice, v we are saying is our denominator, u is our numerator. So when you look at this, it's saying that v is left alone. So that means our denominator doesn't change. The u, you take the derivative of. All right, so what that basically means is you leave your denominator alone, multiply by the derivative of the top. Quotient rule, you're going to subtract. And then again, you do the opposite combination similar to the product rule, where now you're going to do the opposite. You now leave the top alone, that's this u, multiplied by the derivative of your denominator, which is v, v primed. All of that gets divided by b squared. Okay? This little low d high minus high d low over the low squared sounds funny. Looks weird, but to be perfectly honest, most people use that. The reason is just because with the product rule that we did in the previous page, since we were adding them together, the order in which we did the product rule didn't really matter. So if I would have done these opposite directions, okay, if I would have flip-flopped these two as first, these two as second, it wouldn't matter because we are adding. So it doesn't, man, that fingernail is nasty, huh? I have to get a manicure while I'm off. Yuck. So we could flip those. Over here, though, With it being a subtraction sign, it's very, very important that we do it in this order. Okay, pretty much when we do these, you'll be taking multiple choice tests probably after this, at least mostly multiple choice, and every answer will be if you do these backwards. All right, always one of your answers would be if you kind of get the quotient row backwards. All right, so again, low D high basically means the low one, which is the bottom, times the derivative of the high one, which is your denominator, minus the high one is your numerator, the derivative of your low one. And then that's multiplied all over the low squared, which is your denominator squared. So that's what all that weird stuff is saying, what it means. Okay, so let's do 1 or 2. We'll do 1. Your denominator, numerator. Again, the UV stuff can be a little tricky with these. It's not necessarily always the U on top, V on the bottom. What we really want to kind of know is either this guy or just kind of get down the pattern that we're supposed to be following. So what that pattern is, let me come up here, see if I can zoom in so my hand will fit. Okay, so what that pattern is that we're going to take the derivative, so we'll write it as f prime. We first leave our denominator alone, so you're going to rewrite it. Multiply it by the derivative of the numerator, which is 5x to the 4th minus 12x cubed. We would then subtract, and we flip that order around, so now we're going to leave our numerator alone, x to the 5th minus 3x to the 4th. Multiplied by our denominator's derivative, which is 2x plus 7. Okay, all of that divided by x squared plus, oops, there we are, 7x quantity squared. That's our answer. You would not have to clean that up. Not something messy like that. Okay, we'll do some where it's a little cleaner, but right now all I want you to do is get down the rule. So it's low D high minus high D low all over your low squared. All right, that's what we did. This was the low, denominator unchanged, derivative of the top, minus the top, derivative of the bottom, all over your denominator squared. All right. All right, 2, we're probably going to skip because I write really sloppy and big and it doesn't fit under there. So 2, I'll leave you. Again, try it. We're going to do number 3 here for another round. But that's your quotient rule up here. Okay, so it's really just kind of a matter of memorizing it and being able to use it whenever it's called upon. All right, number 3 I do want you to do. If you kind of look, this is the first one where I say find f double prime of x, and then I give you that quotient. So to find the first derivative, we need to obviously do the quotient rule because we have a top and we have a bottom. All right, so go ahead and do that and see if we've got that down. So take a minute and try that. All right, so do that. It's kind of weird sitting here. La-ti-da. Should I take a look around the kitchen? I had to go grocery shopping today. I like bananas, if you couldn't tell. Yeah, we also had Michigan peaches and avocados. I like to make guacamole. Yeah, so there's that. Yep. There's my wife's wall that she writes on all the time. There's my computer. Yep. Here's our work. Okay. We got that? Alright, this one, go ahead and simplify that, and then we'll kind of go through and make sure we all get the same thing. Oh, easy there. Easy there. Okay, so f prime. Bottom unchanged, so 5x minus 3 times the derivative of the top, which should just be 3. Okay, minus the top, 3x plus 5, and then the derivative of the bottom, which is 5, all over your denominator squared. Okay, so we're going to want to clean this up. As a general rule, whenever we start doing second derivatives, which is what this one is, a second derivative, before you really get into your second derivative, you're going to want to make sure that the first derivative is completely simplified. All right, so that's kind of what we're going to do now. We're going to go ahead and distribute the 3 here, take this negative and distribute it. The 5 also gets distributed to these, so it's kind of like we actually have a negative 5 being distributed into this. So we'll go ahead and do that. Whoa. Sorry about that. F prime then is distribute 15x minus 9. Here we're going to take the negative and the 5 and distribute, so we're going to get a negative 15x minus 25. All of that over 5x minus 3 squared. Then as we simplify this, I'm going to go ahead, we have some like terms here. The 15x's would cancel. Negative 9, negative 25 would be negative 34. Also, before we take our second derivative, we're going to simplify this by squaring it out. So go ahead and square that out. 5x minus 3 squared should be 25x squared minus 30x plus 9. Alright, that's our first derivative simplified. Now what we're doing is going through and taking our second derivative. It's still a quotient. Okay, notice we have a top and a bottom. So now our second derivative is your denominator unchanged against the quotient rule. So low d high means your denominator times the derivative of the numerator. The derivative of a numerator, what we're taking the derivative of is a negative 34. That's a constant, so your derivative should be 0 for the numerator. Minus the negative 34 times the derivative of your denominator, which is just your power rules and your constant rule, should be 50x minus 30. And then that whole thing gets divided by that denominator squared. Alright, so that would pretty much be our answer. I wouldn't ask you to simplify this too much. Just know that this would cancel because of that 0 there. You get a plus 34. You could distribute if you'd like. Not really that big of a deal. Okay? Alright, those are our main rules right now. These are just a little variation of it. So I'll give you this one. It says, suppose u and v are differentiable functions. We'll kind of get into that word differentiable tomorrow. Basically what it means is you're able to take the derivative of a function. And then I tell you that u of 1 is 2, u prime of 1 is 1, v of 1 is 5, and v of 1 prime of 1 is 4. It says find the values of the following derivatives at x equals 1. So this is that notation I talked about earlier today. This little d over dx is used to say take the derivative of whatever is inside of these parentheses. That's kind of what this is saying. It's kind of a direction telling us what to do with what's inside of the parentheses. In this case, we're taking the derivative. If you notice, this is a product. So just kind of a little check to make sure we got the product rule down. Product rule is you do the derivative of the first, leave the second, plus leave the first, derivative of the second. If you wanted to, you could interchange those two. Put these two first, those two second. It doesn't matter because it's a sum. From there, you're just going to plug in your value. So you're going to find u primed of 1. So u primed of 1 is right there. So u primed of 1 is 1. You're going to find v of 1, since that's where we're doing it. V primed of 1, I'm sorry, what did I want? Confused myself. V of 1 is 5, so you're going to do times 5. And then times u, v primed, u, 2, v primed, 4. So 2 times 4. 5, 8. Our answer would be 13. Alright? Okay, 14, I'll leave you. It's just a quotient rule. We just did it up here. Okay, so again, here's your quotient rule. Low d high minus high d low over low squared. Or your denominator unchanged, derivative of your numerator, minus your numerator, derivative of your denominator over your bottom squared. So I'll leave that. Alright, C. Notice you have 7v minus 2u. Technically this is a product. I have 7 being multiplied by v. Alright, so let's ignore the 2u right now. So pretend he is not there. So let's say I did that. And let's say the 2u is not even in this problem, and all we wanted to do was take the derivative of 7v. It's a product. This is our first term, that's our second term. So we would technically need to do the product rule. Well, in the product rule, when you do the derivative of the first term, you're taking the derivative of a 7, it would be gone, which is just a 0. And then you would leave your v alone. You add in the product rule. You would then leave your first term alone, so now the 7 doesn't change. And we take the derivative of the second, which is 7v primed. Alright, what do we ultimately get? Only thing you would end up with is 7v primed. The reason I show you this is, if you have a product, which we did here, this is definitely considered a product, 7 times v. We do not need to do the product rule if you have a product and one of your terms is a constant, which that 7 was. So since this is a constant being multiplied by v, you do not need to do the product rule, because this would happen every time. Then when you do the derivative of the first one, this is just going to drop, and all you would get is your coefficient, the 7, multiplied by the v prime. So whenever this happens, we really can just bring that coefficient down, so bring your 7 down, and take the derivative of the second term, and that would be it. So that when we go to this next one, because there was 2 parts to this, all we really need to do is do minus, you can bring your coefficient down, and multiply by the derivative of the second term, which would be u primed. Okay? Alright, from there we plug in our values, so 7v primed is 4. Minus 2 u primed is 1. So we get what? 28 minus 2, which is 26. Alright. Alright, and the next one. Alright, 5. It says, find the horizontal tangents of the curve y equals x to the 4th. You can read that. Alright, keywords here, the idea of tangents are dealing with, if you kind of graph this curve, it sort of looks like this. Okay, pretty rough sketch of what that looks like. Actually looks like a mustache or a scowl. But what you will see is you have a bunch of tangent lines of this curve, an infinite number really, anytime we have a curve that goes on forever. You have a bunch of tangent lines. These have negative slopes, these tangent lines. This had a positive, a negative. However, when you look at like right about here, you have a tangent line that's horizontal. Same right about there. You have a tangent line that's horizontal. Same with this one, tangent line that is horizontal. Well, at these points, if your tangent lines are horizontal, what we already know is the slope of any tangent line is 0. Well, slope equaling 0, so here, slope is 0, basically the same as saying your derivative equals 0. So when we're looking for horizontal tangents, we're looking to see where our derivative equals 0. So if we come back over there, that's our function. If we go ahead and take our derivative, that's 4x cubed minus 8x using our rules from the front. What we want to know is this. When does our derivative equal 0? This is our derivative, and we just want to know where this would equal 0. So you are going to set that equal to 0. Whoa. And figure out where we get our 0. So you have a common factor of 4x, pull that out. What's that leave us? X squared minus a 2. Continue on, 4x times, we'll say x minus a root 2, x plus a root 2. And we get 3 points where this is going to happen at x equals 0, root 2, and negative 2, or negative root 2. That's where our horizontal tangents are at. Okay? Alright, last one. Find the equation of the line perpendicular to the tangent of the curve y equals x cubed at negative 2, negative 8. Alright, here's kind of what this is asking you to do. If I can get the camera situated. Here's what y equals x cubed looks like on a graph. Okay, beautiful, I know. I see I missed the origin there. I should go through the origin, so pretend it does. Alright, here's the point negative 2, negative 8. Would be somewhere over here. So we'll say this is negative 2. In my defense, I'm trying to write through the screen of this camera, so I can't really see my hand except through the screen. So cut me a little bit of slack. Alright, from there, here we have a tangent line if we wanted. This you've done a few times, written the equation of our tangent line. What this problem is just saying is write the equation of a line that's actually perpendicular to the tangent line. So we actually want to kind of write this equation right there. Okay, again, beautiful graph. Alright, so again, in order to write the equation of a line, you must always know a point and a slope. In this case, we want a perpendicular slope. The point is easy. The point is that guy there. The slope is what we're hopefully, equating at this point, is your derivative. So y equals x cubed, you're going to take that derivative, 3x squared. That's our derivative anywhere. We want to know what is the derivative at this point. Well, our derivative will always equal 3 times our x coordinate squared. So we need to look at our point, see that our point has an x-coordinate of a -2. Plug it in. Simplify, and you get a slope of 12. That's our derivative, that's our slope. Then just be careful. Normally for the line's tangent, what we've been doing up until this point, this would be your slope. We would say this equals a 12, but since we're going to do a perpendicular line, since our derivative gave us a value of 12, we're actually going to use a -1/12 for our slope. So, using these two pieces of information, our point and our slope, we should now be able to find the equation of that line. Alright, so point, slope, we'd have y plus 8 equals a -1/12 times x plus 2. I didn't really specify form in terms of standard, slope, intercept, any of that good stuff, so we can just leave it in point slope form. Okay. All right. Hopefully we got all that. Again, I'll probably be back next week on Tuesday. This hopefully we're good with, and we'll continue to move along. If you have questions, go ahead and you're more than welcome to email me. If there's anything I could put on the video for the next one, I'll try to answer it real quick. If there are, I won't even say who emailed me and asked the question. But if you do have a question or two, just shoot me an email. I'll put it on there. Suppose I can look at you for this one. I'll put it probably on the next video if you want. Answer it real quick, hopefully get things squared away. And then again, just don't get too worried about your grades right now. I know that's not easy for some of you, but we'll make it work and make sure everything is squared away. So, have a good day, and I'll see you the same channel tomorrow. All right? Okay, thanks guys. See you later. Bye.